In this lesson, we're going to look at creating a structure for an item or a bill of material. So we're going to identify the setup steps for structures and how to create a product structure or bill of material. So what is a structure or bill of material? A bill of material or structure for a product defines what goes into what. One of my friends used to call it's a gazinta. It shows you what goes into what. It tells you all the different components. It can list sub-assemblies right down to every nut, bolt, screw, washer that goes into the product to make it. Within the application, the structure we're looking at before the bicycle, it has a frame, set of handlebars, set of pedals, pair of wheels. In this case, the wheels are already assembled. So the wheel itself is a sub-assembly which has the spokes, the gears, the inner tube, tire, and the rim. You can have multiple structures for a part. The system is flexible enough to let you create not only something to build from, but you can plan from. You can set up a bill of material or structure for spares. If you want to plan for spares, you can use a planning bill. Maybe you have long lead times and there are certain things you want to start getting into the plan so the planning engine can see it and get them on order. There's the primary structure, which I'll talk more as we go. And you can also validate against the life cycle to make sure that you don't put a prototype part on something that's released for production. Structures are org specific, but you can share the org across multiple orgs. And the way to do that is with the common structure. So if I create a structure in a particular org and I comment it across multiple orgs, then I have a single source of truth for that. And I can build it whenever I update the source, then it'll push the changes out to the other orgs. And it's very common if you're using like the configurator to create the structure in your item validation org where your sales orders are looking for what it can sell and then share that out to wherever it's going to be built. So what are the setup tasks? Glad you asked. We've talked about flex fields previously. So for your structures or bills of material, you can have descriptive flex fields at the header level. You can have them at the component level, the component substitute level, clear down to the reference designator level. Plus, you can create multiple structures. Just remember that the primary bill of material type is the one that's seeded. So item structure type details. We mentioned that we have structures, the different types of structures. You can have the flex fields. There's also some validation rules for the items. Some of those are inherent in the system and some of them you can enable. The one that you can enable is the lifecycle validation. Again, that makes sure that you don't put items that are obsolete or in prototype or pre-production onto an item that is in production or ready to go out production. That would cause you some problems going forward. Your primary bill of material is generally what the system defaults to for what it's going to make, plan, and cost, but you can change the cost, but you can change the name if that to production or whatever makes good business sense in your world. You've got that flexibility. So what is the process? Your manufacturing engineers generally work with your design engineers and the product managers or a product data steward to make sure that the information in the system is complete and accurate. So you can create the product structure, manage it. You can do comparisons between different revisions or different products, whatever it is you want to look at. When you create new bills of material, you can create them as brand new. So start from scratch. You can copy one over and then make the changes that are necessary. And as I mentioned, you can create from a common bill. So if you need to ensure that multiple orgs share the same structure, then you can make it a common structure from wherever that source org is, that single source of truth. And when the structures are common, any changes made to the structure in the source automatically get pushed to the target organizations. So creating from new, you need to tell it what org you're going to create it in. And in this screenshot, you may have figured out by now that 000 is the master. So we won't ever build this particular item in this particular org, but we could share this structure across multiple orgs. So what are we going to make it in? What's the item number? Click on the create from new, and then you choose what the name's going to be or the type. It'll default to the primary, but if you need and or want it to be something else, you can set it to that. And then effectivity control. Effectivity control is either going to be done on a date. So as of the first of the month, this is what the structure is going to be like. If it's going to change, and maybe the next month, we're going to change it. You can also do serial effectivity, serial and unit. So you can say when we get to a specific serial number, this unit is going to be configured starting with this new configuration. So you got a couple different ways to do it. The latter doesn't care what day it happens. It just says when that unit is being built, it's going to be built to this specification. You can add components to the structure, a couple different ways to do it. I personally like to hit the little plus, drag a bunch of stuff in and drop it on there from the little window. We'll show you how to do that. You can add substitutes. So the primary bill is how you normally want to do it, but you can identify substitutes if you need to. You can ask the system to build and plan with the substitutes. So if I can't get the primary part, I can change to the substitute. You can also add reference designators, and that generally defines where the item goes on that particular assembly. Used to use this go on printed circuit boards when they had through-hole parts and you could actually see the parts. Now everything's so small, it's kind of hard to see them. But on the board, they would silk screen the board and they would actually put R1, R2, R3, C1, C2, C3, and you could see what went where, and you could put that in the system to help identify where the parts went. This example is where does the screw go? I'm not sure why the seat is highlighted, but it's you see the blue line on the M1 screws, reference designator, it defines where the screws go. Also, one of the tabs for the structure shows the where used. So when you click on that, it'll show you where in the subassemblies a particular item goes. So we have 7 screws. I think 6 of them are in the pedal assemblies, one's in the seat, or vice versa. You can do a summary view of the structure. So in this example, when you go to the summary view, you can see that there's a total 11 screws. And when you go to the details, you can see where each of those screws are used. That's pretty handy when you're trying to figure out how many of what we need to actually build the assembly. Then that last tab has the change orders associated to that particular structure. You can see the change orders that have been implemented, and change orders that are pending. When you create a structure from a copy, there are some rules against surrounding that process. So the structure effectivity type, we have date, serial, unit, and or lot. So on the date, you can copy everything. If you're copying from serial, you have to go to serial. And if you're copying from unit, you have to go to unit effectivity. We mentioned creating from common. So again, that lets you create a bill of material in the source org, share that across multiple orgs, has a single point of truth to manage that particular item. And again, it's common to do that if you're doing assemble to order, configure to order items, and you create them in the item validation org for your sales orders, so the system can recognize that. It's generally your item master. That's the most common practice I've seen. Only once in the last 25 plus years have I seen somebody have a different item validation org. Common structure maintenance, as I mentioned, you have that single source of truth, but wherever you share it, you can update the supply type, sub-inventory locator, operation sequence, and the cost roll-up process. So you do have some of those attributes that you can manage at the individual org where that item is being used. I mentioned there are some validation rules. So when you create, copy, or change a structure, some of the validation rules are the lifecycle validation rule. When that one's enabled, it ensures that only components in the same lifecycle or higher than the parent can be added. The only exception is made for an obsolete lifecycle. Component lifecycles in that cannot be added to the structure. Or assemble to order, pick to order, phantom structures where the parent item has available to promise components set to no. You'll receive a warning when you add components that have either the item attribute checked, available to promise, or ATP set to yes, or the ATP component is set to yes. The warning will display the order details for the parent items. Specify no for ATP items or components. So just know, make sure that you're consistent there, and make sure that if you're using the available to promise and the global order promising, that everything is set up properly. You cannot add an optional component to a structure that is neither a model or an option class. You cannot add a component whose planning percentage is not equal to 100. And now we're going to go take a look. So we'll see you in the demo.